Okay, everybody, this is chapter 2, section 1, beginning solving equations. So this chapter, we start very basically, and then we're going to move on and keep building on the different principles and concepts that you got. So this chapter, each section we go to, you're kind of coming back to this one basically, okay? The first thing we have here is the definition for an inverse operation. And so if you go ahead and write that down. Once again, just a reminder, as you're taking notes, please make sure that if I'm going too fast and you need to get caught up, hit the pause button and get your notes caught up and then hit play again, okay? So an inverse operation is an operation that undoes another operation. So let's just kind of write this down. When we're doing a particular math operation, the things that we know are to be able to add and subtract and multiply and divide, okay? So if you could write these down, let me get this a little bit tighter here. Okay. So an inverse operation, when you're adding something, to undo that is to be able to subtract, okay? If you have an operation, a problem, and you're subtracting, to be able to undo that is to add, okay? When you're in your particular equation, if you're having to multiply, to be able to undo that is to divide, okay? And then if you're dividing in a particular problem, to be able to undo that, you're going to go ahead and multiply, okay? So those are all inverse operations of each other. And so we're just going to have to make sure we identify what we're doing, then be able to do the opposite to undo it. When we undo something, we're solving the equation, whatever that might be. Okay. Down here, just kind of going over what I just kind of talked about, the additions and subtraction or inverse operations of each other. The multiplication, division are also inverses of each other, okay? So they undo each other. So an example of this, if I have to solve this equation down here, x plus 4 equals 2, I'm trying to get x by itself. So I'm going to identify the operation of how x and whatever number might be connected. In this case, is connected by addition. To undo that, I'm going to subtract whatever that value is. So in this case, I'm going to undo the addition by subtraction, and I'm going to go ahead, but in math, I got to always keep things balanced, so I have to do it to the other side, okay? So what happens here, that goes away, you're left with x. Over here, I'm going to combine these two, I get -2, okay? So in this particular problem, this is actually a division problem, okay? So division is always, in math, can be written as a fraction. So if it's division, then I'm going to undo it with multiplication. So I'm going to be able to go ahead and multiply. And when we have a fraction like this, I'm going to multiply by the denominator. Okay, actually, I'm going to put it up here so we don't get confused. Sorry about that. Okay. So over here, I'm going to do it to that side, and I have to do it to the other side. Okay, so just identifying the denominator, that becomes how to undo the divisions multiplied by the denominator. This is just going to go away. I'm left with x. And then over here, since I've changed this to multiplication, 2 times 3 gives me 6. Okay. All right, so the bubble approach there, not really a big fan of, because this is the way I'd really like to see you do it. We're going to, once again, identify what the operation is, and I'm going to do the opposite. And let me back up for just a moment. You know, sometimes, you know, mathematicians, we do things to see if you could just follow the rule. This number right here is still a positive 3, and up here it's still positive 3. So no matter how this is written, I'm still doing the opposite of those numbers, or to undo it, I'm going to do the opposite, or we call it the inverse, okay? So just understand that these two things right here, they're the same thing, just written a little bit differently. I'm going to do the same thing to undo it. But that second one seems to really bother students sometimes. What do I do here? Because it's not like it's supposed to be. Okay, well, it can be really written any way. All right, so let's go back. Identify the operation is plus. So I'm going to do the inverse is -3. And then I can go ahead. I just like to cross those out because it's really to make it go away. You're left with the x. 27 minus 3 is 24. Okay. And just for kicks, I'm going to go ahead and do this one like I was doing before. I'm turning it around. So to undo this is really to isolate the x or the variable, whatever it might be. Look at what is the sign of that number. It's positive, so to undo it, I'm going to subtract. But I got to make sure I do it to both sides. This is going to go away. You're left with x. 27 minus 3 is 24. I get the same answer. Okay. So just make sure you recognize things, how they're written, to be able to solve it. Okay. Okay. So problem number 2, identify what is the operation of subtraction. So the inverse of that is to add, and I add whatever that value might be. In this case, it's 4. They're going to go away here. I'm going to be left with x. 12 plus 4 is 16. Okay. In the old days, when I was taking Algebra 1, my teacher maybe write a check mark, maybe take that x value, plug it back in for x, and show that it actually works. Okay. That's something that you could do, I think, pretty easily in your head, but you always want to make sure that you're right. So go ahead and do that. Okay, problem number 3. We have this would, remember when numbers are kind of, I call it stuck together. There's no operation sign there. There's no addition or subtraction. They are being multiplied together. Okay, so we need to, sometimes that confuses kids. Well, what are they? Well, they're multiplied together. So I go to the inverse of multiplication is to divide. So I divide by what's in front of the variable. So in this case, I'm going to go ahead and divide by a -2. So this is a place where we can make mistakes. You got to remember your rules about multiplying and dividing signs in numbers. This is going to go away, but it was a negative divided by a negative, so I have to use a positive answer m. On the right side, a positive 36 divided by a -2 should give me a negative answer, and 36 divided by 2 is 18. Okay, and this example, this is just showing me that I can go ahead and identify that a fraction is a decimal or is a division problem. So I'm going to identify the denominator, it's 4, and to undo division is to multiply. So I'm going to show multiplication, and all I'm really trying to do is get rid of the fraction over here, so that leaves me with x. And then just being careful, a negative times a positive is a negative answer. 9 times 4 gives you 36. Okay. On this particular problem, there's a couple ways to do this one. This is showing multiplication. Okay, so just know that, you know, this is just like if it was 2m. The 2 and the m were put together by multiplication. In this case, the 4/5 is put together with multiplication. So you're going to go ahead and divide both sides by that. Okay, but the rule with division is to flip it and multiply, and I have to do it to both sides. Okay. So here, these just go away. I'm left with a variable. All right. Here, you can multiply a couple different ways. I can cross cancel right here. Okay, or I could just multiply the tops. So I'm going to do that for you right here. I'm going to multiply the tops. I get, 140, 200 over 4. Okay, and then 4 will go into 140 35 times. So you could do it that way if you want. If I cross cancel, I get 7 times 5. That gave me 35 that way. So whatever way you feel comfortable with, All right. So that's how you do all those. You got to identify what's going on by adding, subtracting, multiplying, and dividing. You got to understand what the reciprocal is to be able to solve it. Okay. We got a problem down here about macaws and toucans, and we're going to write an equation for that. Okay, so with the toucans and macaws, there's a relationship by the length of their sizes. So they kind of give us an idea of what each one is. They tell me that the length of an average toucan is about 2/3 the length of an average macaw. So what I did was I said that the toucan is 2/3 of a macaw. So I wrote out a little equation for that. From the other information they give me, that they tell me that a toucan, that the one they have here, is 24 inches long. Okay. So I substituted that in for T. Now that I've got that, I'm going to be able to go ahead and answer the next question. I can find out what is the length of the macaw. So this is a multiplication problem. They're put together by multiplication. So I'm going to undo that by multiplying. So remember, I got to flip the fraction. By dividing, I'm sorry. I'm going to flip the fraction and multiply it. Okay, sorry, that's multiplication. Dang it. Hold on. Going too fast here. Okay. When you divide by a fraction, you have to multiply by the reciprocal, which means flip it. That's going to go away. I'm going to get just the macaw. I'm going to go ahead and multiply that out. And I'm going to get that the macaw is going to be about, let's see, doing my head. Let me see my mistake. I made that 34, not 24. Okay, when I multiply that, I'm going to get 72 over 2, which gives me 36. Okay, sorry, wrote the wrong number down. Got myself caught up. Okay. All right, so I think that takes us to the end. Please make sure that if you have any questions, please ask. Do the classwork, practice those a little bit. They should be pretty straightforward for a lot of us, but please make sure you ask. Okay, thanks.